Hello and welcome to SLOconf. I'm Jason Greenwell. I'm the SRE leader for Ford's Model E division, and I'm here today to talk a little bit about promise theory and how it applies to SLOs. So first off, it's important to understand what promise theory is just in general. And it's really just a method of analyzing and studying complex systems and understanding kind of the risks and things within. It talks a lot about independent agents and different independent beings within that system, and then how they can cooperate to make something else happen. Right. And this very much so looks like the distributed systems that we all probably work on from time to time. The important things to really take away from it, though, and of course, I pulled all of this just from Wikipedia, is that the complexity rises exponentially with the number of agents. So if you've got a very distributed system, there's a lot of complexity in there, and that your uncertainty and risk increases if you have incomplete information about all these agents and how they're performing. So if we think a little bit about kind of our own careers. And if you've been in this game for a little while now, one of the biggest changes that have happened in the past 10 to 15 years or so is really this move away from these monolithic, big top to bottom applications that contained everything in there to more of a microservices architecture. And, the monolithic architectures were all tightly coupled and it doesn't scale and it's difficult, right? And it's very hard to change because you have to test everything up and down the stack. So in reaction to that, we created these microservices that are, agile. They're small, simple things that you can change. It's scalable because the independent parts can scale up and down based on load and how things are being used. And they're reusable. You don't have to re-engineer your cart or your checkout process every time you want to build something else. You can just use all of that stuff. But with all of the, it's so much simpler in a microservice world, we kind of left out one important thing, and that all of these microservices rely on, layers upon layers of trust. And the complexity of the system didn't go away. It just moved, and it moved out of those individual applications. Now there's more points of failure. There's generally more teams involved if you're reusing things across teams. And if there's more teams, there's more backlogs. And then just making a change starts to get more difficult when you have to start fighting for priority. There's more and potentially varied infrastructure, right? Where I might be running in one cloud, you might be running on-prem, we might be using different databases or different technology stacks altogether. And you've injected the network because, as we all know, it could never be DNS. That's the problem. So you just have all of these different layers of trust that you have to just rely on people in order to really provide these experiences. And if we think about, promise theory, and let's talk about agents and intentions, and apply that to microservices, the agents and actors are really the APIs and the API consumers and the different parts and components that make up those APIs. And if we just limit it to talking about APIs, the API intentions or the promises that are being made by those APIs are really kind of their API contracts, so those Swagger and open API specs and things like that. You send me this, I'll send you that. And the SLOs, those are those non-functional performance promises that we're making that say, hey, I'm going to be up 99.9% of the time, and I'm going to be faster than 200 milliseconds. And those are really those SLOs that we need to watch over time. And it's important to note that an agent can only make promises on their own behalf. So if I'm relying on a service from one area or a different infrastructure component, I can't make promises on that infrastructure component's behalf, right? I can only talk about the things that I'm in control of. And so let's take this, into a different kind of place. So let's say that a bunch of engineers decided to go off and start a restaurant. And we'll just, of course, we love microservices. So we're going to try to build this cheeseburger restaurant and do it all with individual components, right? So we have a customer comes in, he wants a burger. He wants a burger this big. We're going to set SLOs for ourselves. We won't tell the customers if that's what that is. It's kind of weird. They just expect it to work. But we're going to make sure that we get the right burger out there 99% of the time, and it's going to be less than 100 seconds 99% of the time. And like I said, us engineers, we blew this apart into a whole bunch of different microservices. So it's really simple. Each one of the parts is very easy to manage, and we can scale them as we go. So if we've got one area that's focused on making sure the buns are toasted, they can toast the buns really, really well. one area that just chops lettuce, the area that does the patties in case we get a run on people that want double cheeseburgers, they can scale up and start making more. But in order to provide that single burger, now we've split this across a whole bunch of different areas. And so if we think about that in kind of a little bit of a less silly manner, but stick to the metaphor, our applications are a bunch of layers like this. So we might have a UI and we might have an API gateway that we rely on in order to get our microservices out there. We're probably running on some kind of a cloud platform and use databases and a number of other things. And all those have to come together in order to meet that customer experience and make sure that they get, what they're expecting and what we've told them they're going to be getting. But it gets worse, right? Because in these distributed computing environments, it's not just our burger that we have to worry about. A lot of these things are other full boat applications that have their own stacks. And so it's a lot of burgers to provide this experience as they go. And so starting to understand how this whole ecosystem is behaving and what we can expect from it is really critical. And that gets to kind of the key point in promise theory and how we can use SLOs. So credit here to Mark Burgess. He's got some excellent videos about promise theory out there. Pulled this from one of his YouTube videos, and I couldn't have summed it up better if I tried. But the main idea of promise theory is you have to document and communicate what this intended behavior is. So you have to document and put those SLOs out there and what you're expecting of yourself, and you've got to track it so you can understand it and predict those outcomes over time. And you can really then know if these APIs or microservices or whatever they are that you're relying on are actual reliable agents. And you can take the right kind of actions based on what you learn there. And we talk about, documenting and communicating those intentions. SLOs are really, kind of those codified and published promises, right? The performance aspects, like we were talking about earlier. What are my API's performance expectations? And then how am I performing to those expectations? And at the end of the day, am I a reliable agent in this overall ecosystem? And then when we talk about publishing it, and making sure that these SLOs are out there, we have to publish and set consistent and transparent SLOs. These, shouldn't be secrets. And the first part of that is doing it consistently. Last year at SLOconf, we launched the SLO development lifecycle, right, which is a methodology for going through and making sure that you're kind of setting the right SLOs. And if you do it across a large organization, you'll be setting them consistently. And so everybody's speaking the same language. So go check it out at SLOdlc.com. Once you've got those SLOs, you got to track them, got to get them out there mechanically looked at. Those are just a few in Google Cloud Monitoring, for an example. And then you have to get them out there in front of people and make them really transparent and show how to do it. You can do this a number of different ways, right? I'm of the opinion that you want this out there in the development platforms that people are using, such as you might choose to use Backstage.io that was put out there by Spotify. So when you're going to onboard to an API, you should see how it's behaving and what's going on up and down the stack. And you can really make it easy to get all of that information very consistently for all of these components that make up your ecosystem, which is what we're doing and how we're pushing these things through there, and to try to really make sense of the chaos and understand the promises and if we're keeping them up and down the stack. So thanks, everybody. I hope you enjoy the rest of the conference. There's going to be a lot of other good talks out there.